For this video, we're gonna give a mini lecture about Newton's third law, in addition to elastic and inelastic collisions, and then we'll finish by talking about example problem number 8. So to begin, we'll talk about Newton's third law, which is that for every force or action, there's an equal and opposite force or action. So pretty much all that's saying is that, say, we have a ball and it's on the ground. The force that the ball exerts, and it's not moving, the force that the ball exerts on the ground, which is mg, there's the same force that to keep it still and have it not move, the ground exerts the same force the ball exerts on the ground on the ball. So we see this in our daily lives by just standing on the ground. We exert force on the ground and the ground exerts force on us. And if the ground didn't exert force on us, of course we would be sinking, but next, we'll talk about elastic and inelastic collisions. Pretty much, for this specific example, just in the case of a bouncing ball, if the equation is elastic, the bouncing ball would return to its height every single bounce, and it wouldn't eventually get smaller in the bounces. So ideally that's what would happen, but usually, whether it be because of friction or other factors, a bouncing ball is more of an inelastic collision because it can't be perfect and bounce exactly back up to where it was. Okay, so now we'll go on to the problem, and here I'll show it and then read it. So the problem states that a ball of mass m is dropped from rest from a height h and collides elastically with the floor, rebounding to its original height. What is the magnitude of the average force applied by the floor on the ball during the time that the ball is in contact with the floor? So for this, we know that a ball is just going to have its force, because it's in the air, it's going to be going down by mg. And so that's going to be the force. But what the question is asking is, what is the average force applied by the floor? So the floor is going to push the ball back up. So remember, we can use Newton's third law, and this will be the equal and opposite force. In this problem, it's important to note that they say it collides elastically. So all kinetic energy is retained, and the ball bounces back up to its original height. So that means that we can use Newton's third law, which tells us that this force mg that's going downward, the same force, the force that's pointing back upwards will be the same, because it's an equal and opposite force. So when we look through the answer key, they give us 0, mg, 2mg, 4mg, and it cannot be determined without knowing the length of time that the ball is in contact with the floor. So it is going to be mg because of the equal and opposite force. And we know that kinetic energy is conserved, and we use Newton's third law because it's an elastic collision. And the time that the ball is in contact with the floor doesn't really matter because of the equal and opposite force idea. And Newton's third law decides that.